And welcome. It's Tuesday, and that's why you are here watching the Bridge Show. And let the show begin. Ladies and gentlemen, welcome to another episode of the Epic Show here from our IP studio in the basement of our Oslo HQ in Norway. Oh, holy Moses. It will never stop, will it? It's Tuesday, and we are so lucky to have you, Rolf, in the red chair.
Thank you very much.
You know, whenever you come on, we dive deep into the nice, feature set and technicalities often. And today is no exception.
Yeah, this will be a deep dive, but hopefully also some helicopter view as well.
Yeah, because, one thing that is very obvious is and you put it so well, because there is a huge renaissance for terrestrial television.
Yeah, I mean, that is, it's kind of a trend and has been going on for quite some years now. You could say it's being pushed by the need for more bandwidth, like everything, I guess.
Yeah, because obviously, they need more bandwidth too.
Yeah, exactly. Everybody needs more bandwidth. So,
where's the bandwidth?
Yeah. No, high-definition television is a driver, of course.
Yeah.
And but also the spectrum itself. It's becoming smaller because the mobile operators with 5G and these kinds of technologies, they are, of course, infringing a bit on the spectrum, and that means you have less space to do more.
Exactly.
And that's kind of the driver.
So we've seen the going from analog, obviously, to digital terrestrial, and then, of course, now T2.
Yeah.
What's so special about T2?
Well, it is just more of the same. It's more complexity to get more bits through the same bandwidth, and then they are employing different types of signaling processing techniques to achieve that. Yeah. And now we are almost at what's theoretically possible. We're getting down to Shannon type of levels, which is kind of, it's becoming super complex. Yeah.
But one thing that we've seen, because we do monitoring, and we've been doing monitoring for terrestrial for 18 years.
Yeah, yeah, exactly. I mean, our first T2 products were in like 2014, 2015, when T2 was new. Yeah. But the Renaissance part that you're referring to, that is taking place now and maybe in the last couple of years. So we've had some really nice uptakes in this area lately.
Yeah, because it's a very complex technology, and that of course necessitates the ability to monitor and understand it. And we have a nice diagram that basically illustrates some of this. And shall we go through the points where it's natural to monitor?
Yeah, we can do that.
Because we can start with the signal chain. Norway is a great example, isn't it?
Yeah, I mean, if you look at it from a sort of top view, a typical system, it will have a central facility, typically one, but in some cases two for backup. Yeah. You will then have a number of transmitter sites, and these transmitter sites will be scattered all around the country typically. Exactly. So in Norway, like you referred to, we have something like 450 of these because we're a long country and lots of mountains. Yeah.
Lots of mountains. So we have quite a lot of equipment on mountaintops, don't we?
Yeah, yeah. That's exactly a good point, because, I mean, you don't want a big, beefy server up on a mountaintop. No. You want something that will keep working for a long time, and so you don't have to fly up with a helicopter to reboot it.
No, that's very sad, but you have to do that, obviously. And that's also one of the reasons why embedded technology still is always very, very attractive into these let's say, systems.
Exactly. Yeah. No, I mean, embedded type where we have focus on long mean time before failure. We have focus on robustness and stability, power usage.
Power usage, that's an important part, because a server uses about 300-400 watts.
Yeah, exactly. And the typical box from us that you put on a mountaintop would be a VB120, with consumes maybe 15 to 18 watts, something like that.
You can run that with solar power.
Yeah, that could be possible. Yeah, that could be possible.
Well, so we start with that you have of course a main site that is feeding the signals.
Yeah.
And typically then you feed signals via 2 redundant systems.
Yeah.
Or let's say an IP network to get it to the transmitters, but with satellite backup maybe.
Yeah, that's a very common scenario in many countries, where they use, like you say, a satellite link as the failover if the land-based lines are cut for some reason. They're being cut by a digging project somewhere, or you never know.
Oh, that happens all the time.
Exactly. So then they do an automatic fall over to the backup link, and yeah, exactly. So the technology tying together the central facility and these transmitter sites, that in modern systems or in current systems, it's often IP based.
Yeah.
So it's a system running with normal IP, MPLS in many cases type scenarios. And in some other cases, it can still use ASI type point-to-point links. That's also still quite common. So.
Yeah, because one of the things that really matter in this technology space is reliability.
Exactly.
That is important part. Cost is of course a big part, but reliability is trumps that.
Yeah, exactly. I mean, one transmitter tower can cover a large city. Here in Oslo we have 3.1, and that's like 700,000 people on one main transmitter. So.
That better work.
Yeah, that better work. So.
Well, we're on it. We are monitoring it, so don't be afraid. Don't be afraid. So obviously, we've been very, very successful with T2 monitoring. We've been in multitudes of different projects, and also they utilizes a lot of our visualization tools as well.
Yeah, exactly. I mean, if you look at some of the overlying systems that we have on top of the architecture. So those could typically be, we have what we call a video bridge controller, and that's a piece of software that we've had in our systems for, since we started basically. But this has tools like you can build up dashboards that gives you instant information about each transmitter site, for example. So you can have constellation diagrams or MER readouts to check the quality of the modulator transmitter, and you also have type of reporting functionality inside the VBC.
Yeah, that's of course is pretty important, because you really need to know what's going on, and also to be able to know that nothing is going on.
No, exactly. So
for documentation purposes.
Yeah, yep. So that's exactly true. And in many cases, it's regulatory a need, or actually set by law in some countries, that you have to prove carriage of your television services, and then you have to document the amount of time that you're down, or you're not allowed to transmit.
No, exactly. I totally understand that. We're going to basically have a short talk about this, because we can talk about DVB-T2 for hours.
Yeah, it's a big topic. Yeah.
It's a huge topic, and the more I learn about it, I'm kind of like flabbergasted about both the complexity and the amount of different system architectures, and of course that influences how you monitor. Because if you have a different architecture, you design your monitoring system a bit different.
Yeah.
And we have, focused a lot in all our years on training.
Yeah.
And to actually be able then to utilize these systems to the maximum.
Yeah, exactly.
So we actually had the academy for many years, and it's actually headed up by our amazing Martin Crowley. And let's see what he's got in store for us. And hello, Martin. You are live with us from Southampton, are you?
Yeah. Hello, Simon. Hello, Rolf. Nice to see you again.
And what have you been up to? Because you know we stressed the importance of training here, and so give us you know, what is Academy all about, and where can you find it, and again, what's new?
Yes, of course, Simon. Yeah, but before I start, that sting, it's wonderful. It's a really good bit of graphic design there. I love it. I love it to bits. So it sort of coincides with a little bit of a relaunch of the Academy. I mean, we've always been there in the background, training as customers, business partners, end users, and so this is a little bit of a relaunch. We're pushing out training to all of our business partners. I'm organising with our sales managers training in the regions. Of course, it's all still online at the moment, but we're getting business partners taking up, and I'm personalising training straight for the business partners. And the other thing that I'm going to be doing, in fact, I've actually started it already, is I'm going to refresh all of the training videos that are on our the training page of the website. And we're going to be incorporating that fantastic new top and bottom sting, and just bringing all of the videos bang up to date with all of the fabulous new features that the guys have been adding.
Oh, this is excellent. No, thank you, Martin, and we are really looking forward to that. And again, go, go, go. You know, training is the best tool to get people to utilize the systems to the maximum. So thank you, Martin, and thanks for the update.
Not at all, Simon. Good to talk to you.
Well, he's not slacking off. He's busy,
Yeah.
which is great. This was, you know, a very short update on DVB-T2 especially, and we've been very active in that area. We are going to the next program. We are going to talk a bit more about probes, because we're talking about you know, probe technology. And let's see what's up for next week's show. Next week on The Bridge Show, we are talking about the probe technologies. Tune in. Well, so obviously tuning into next week's show is a must. So thank you, Rolf, for being here. And we have a lot of very nice, you know, new stuff coming out, etc. So please stay tuned to this channel. And next Tuesday, we have more updates live from our IP-based studio in the basement of our HQ in Norway. Whew, that is a mouthful, isn't it? Yeah. So until next time, take care, and don't forget to tune in next Tuesday.